Hey everyone, welcome back to the channel. If you are new here, I am Aditya and today we are diving deep into how to protect sensitive data in your .NET apps the right way. If you're using Add Data Protection in ASP.NET Core but not sure how it truly works, especially in production grade setup using Azure Blob Storage for key persistence, this video is for you. We will walk through the official Microsoft documentation together, unpacking every detail needed to confidently set up and understand data protection with Azure without the overwhelm of reading pages of docs. No fluff, no skipped steps, just clear guidance so you exactly know how it works and how to apply it securely. And one last thing before we begin is my request to correct me if I am incorrect at times. As in, I will be speaking very confidently about all the things, all the concepts and implementation surrounding data protection key in .NET Core applications. But if I am incorrect, let's bring that to discussion in comments, discuss together, and together build the right understanding. And with that, let's begin. So, if you Google data protection key in .NET Core and open the first link from Microsoft, you'll end up on this page. And here you'll see that there's a lot of pages. We have sections under which we have subsections if you expand them. And there's a lot of things that needs to be studied. With this video, I intend to save you the trouble and highlight all the important things and connect all the dots so it makes absolute sense for implementation and under the hood details. Also, whenever we are discussing concepts or implementations, you'll find links attached on the presentation slides, and these links will be available in the description below. So if you want to dig deeper or revalidate the things we discussed, you can just go into that link and see it for yourself. Now, a brief overview. Data protection in ASP.NET Core is crucial for safeguarding sensitive information through encryption and secure key management, which means if I am using cookie based authentication for my web app or web API based application, those cookies will contain user session information and I want to keep them encrypted. And for that, data protection key will be used. Importance of keys is that they are essential for encryption and decryption of sensitive data, ensuring that only authorized users can access sensitive information, which will be our web app. And when we are talking about importance of keys, there's the importance of key management because effective key management practices are crucial for maintaining the confidentiality and integrity of data protected by ASP.NET Core. Emphasis on integrity. We'll circle back on this later. So let's talk about implementation. The secret key will be created on Azure Key Vault, and now that needs to be stored at a centralized location from where all our servers can share that key. And for that, we have Redis as an option and then Blob Storage as an option that the official documentation gives. And I must admit that Blob Storage is just feels safer and better, mostly because of its durability. On Redis, you will essentially lose it. There's that risk always there. Blob storage, it's going to be there forever. So that's that. Before we proceed any further, let's make it very clear why a centralized storage system is needed for storing these keys in the first place. So we will have many servers in one region. Let's say we have tens of servers in region one, and then we have tens of regions. And our requests for users will be routed to any random server depending on its availability and the server that is closest and giving the least latency based on the load that it is managing. So it is very possible and it is very practical and happens all the day that a user which is having a session will fluctuate between servers. So first call will land on a server X, the next request lands on a different server which is giving lower latency. So that is happening all day around. And if we don't have a centralized key for encrypting and decrypting the cookies, what will happen is, let's say the first call falls on server 1, it encrypts the cookies and it decrypts it for the subsequent request, no issues. But if the subsequent request falls on another server that is using a different key altogether, it will fail to decrypt the cookie that was created or encrypted by the server 1. So the sessions will fail and the system will crash, right? So it's very essential that the server set of servers share the same key at a given point of time. And code wise, how do you do it is right there. So code wise, it means that we add services.AddDataProtection followed by .persist keys to Azure Blob Storage, and then we have to pass the blob URI with SAS token. Let me know if you are not comfortable with using SAS tokens. We can use managed identities, and we can have that discussion on comments. And then we have protect keys with Azure Key Vault that takes in as argument the Key Vault URI and the default Azure credentials. And there we have managed identities set up as one of the ways. So we are saying this is the Azure Key Vault where you can look for the secret value, and then this is the storage account where you will be storing that secret value. Now, service.AddDataProtection will run only when the service starts. So, because it's a service configuration. So, whenever a server starts, what it will do is it will essentially hit this line of code. And remember, it hits only when the server starts. And at that time, it will go and check the storage account, blob storage container. And if it has a key which is valid, it will fetch it and store it in its cache, the server cache. But if it's not there, what it will do is it will fetch it from Azure Data Key Vault, Azure Key Vault, the secret key, and store it or add it on the storage account, the blob container in the file, and then simply use it. And all the other servers now will simply don't need to talk to Azure Key Vault. They will continue fetching the new keys that are now added. A slightly deeper look into encryption and decryption process. So by default, every 90 days, a new key will be created, which will be used to encrypt and decrypt the data, the sensitive data in your application. Now, when new key is created and the old key got expired, we want our system to be seamless, as in the integrity of the system should not be disturbed. And we'll circle back in much more depth when we have the complete understanding and we'll see the problems arise. Then we'll find out how these seamless keys are being exchanged. But right now, let's leave that. The thing that I want to set your attention on is how do we change the period of default 90. Now, this is pretty straightforward. At whichever place in your application you are performing service configurations, you will essentially add a configuration on your service for add data protection. All you need to do is also pass a method that add data protection supports, set default key lifetime. Now here in this example, we are setting it to 14 days. If you don't call this explicitly, by default it will be 90 days. But if you want to reduce it, you can always explicitly call and pass the number of days that you want to expire the certificates, the secret keys. Now, if you ever look into the file that is storing the keys, you'll see that it keeps the outdated keys as well. It keeps appending the new keys as the expiration approaches and a new key is needed. The reason we do it is for backward compatibility. I mean, there are so much of gaps in what's actually happening if we think through. So let's try to think through and come up with questions. There's a lot, believe me. Let's say we have 10 servers and all 10 of them have the same key, and now that key got expired. Remember, all the servers still continue to have that key on them in their cache, and they communicate with storage account and key vault and get the new key only when the server restarts. Now, at any point, for some reason, whatever reason, a certain server just performs a restart. So now 9 have the older key, the 10th one which got restarted has the new key. So whenever request falls to this server, the flow will break. And let's assume that 5 after a certain point of time, a couple of servers more restarted, and now we have 5 servers that has restarted and 5 that didn't. Now the five of them have a different key, five of them have a different key, and the flow will break. How do we ensure that this does not happen, right? So we need backward compatibility, and we need to ensure that we are switching from an expired cert to the new one in a uh, very foolproof planning manner, right? So let's see how that's done. So it's all well planned and taken care of, but as a dev, we are implementing this, so it's worth understanding how it's being taken care of so we have the peace of mind, right? So first question is, will the key that was fetched when the server started remain indefinitely in the server cache until and unless the server restarts? The answer is no. They are fetched every 24 hours, and the information is there on this doc. But how are they fetched is the next question that comes to my mind, because I don't see it in my code. I just see it service.AddDataProtection. Well, the data protection system exposes an interface iKey manager that is used and that takes care of internally in the library of periodically pinging and checking every 24 hours. So that's internally being taken care of by iKey manager, and the data iData protector provider has that, and all the details are again there on the documentation. So now we understand that it's out of box support for us, that we have key manager keeping checks on the storage account for the key expiration every 24 hours, right? Now our next question is, when the key got expired, how do we ensure that all the servers move to the new key at once and there is no disparity state where certain are on one key and certain are on another key? So again, the details are on the official docs, but what is happening is, essentially, when a key is created, it is automatically given an activation date of now plus 2 days and an expiration date of now plus 90 days. Essentially, we have 2 days of buffer that will allow that all the servers, the new keys are propagated. How? Because 2 days are 48 hours, and remember, we now know that the keys on cache are not going to stay indefinitely but are going to be refetched on the cache every 24 hours. So it is safe to assume that within 48 hours, one fresh fetching did happen. And what happens is, the secret is rotated in a manner that the storage account will now have both two keys: the new key, which has a buffer of 48 hours, 2 days, and the old key, which is currently active and set to deactivate in 2 days. So the servers will fetch both the keys, but will not start using the new key for encryption and decryption unless it's the time. It just fetches it but keeps using the old key for encryption and decryption. Now, in 48 hours, it is safe to assume that all the servers will have fetched the new keys as well, but nobody is using it. Once the 2-day buffer is up, all the server will start using the new key. So that way we prevent the disparity, and that's how under the hood we save and have a very cohesive experience. And lastly, when I'm integrating add data protection on my web application, maybe I am facing some issues for which it's not working properly. Or if it's working properly, I do want to enable the logs on Visual Studio so that I can see what's happening. Is it working fine? If there are issues, what are the issues? And I want to see all the library level nitty-gritty details. So in order to do that, it's pretty straightforward. You just have to add this configuration on your app settings.json, and that will be your, if you are doing it locally on on dev on local, it should be app settings.dev.json or whatever that you have for local setup. So that will start pushing logs on your Visual Studio. That's that. And that's a wrap. With this, you guys are now the new experts in add data protection in .NET Core web applications. But wait, I have one last question for you, and that's, if my server or service actually already uses SSL certs, and that means that the communication between client and server is secure by SSL certs. That means the data is encrypted, and safe. So the cookies are already safe, right? Do we really need add data protection? What are we protecting it for? Are we encrypting the encrypted data? What's happening? Do we really need it? Uh, so I assure you, we do need it, and all that we learn is not a waste. But yeah, let me know your answer to this question in comments and we can have a discussion. Thanks for watching this video. I am really glad if this helped you. Give it a thumbs up, that will let me know.